Let's get a sketch of the rational function using domain, asymptotes, holes, and intercepts. Up first, we want to find the domain. To do that, we want to set the denominator equal to 0. Something that may help us is to factor the denominator. So two numbers that multiply to -6 and add to -1 are -3 and 2. Set each of those factors equal to 0. And we get x is equal to 3 and x is equal to -2. And we'll actually say not equal to since these are domain restrictions. As a reminder, there's two ways to denote the domain. One is using set notation, all x, such that x is not -2 and x is not 3. An alternate way to denote the domain is interval notation. -infinity to -2, union, -2 to 3, union 3 to infinity. To find vertical asymptotes, we want to first see if the function reduces. Notice the top is already in factored form. That's convenient. And now that it's in factored form, we can look to see if there's any common factors in the top and the bottom. We don't have any common factors. So we're going to set each of those factors in the denominator equal to 0 and solve. We get x equals 3 and x equals -2. This time we have two vertical asymptotes. To find holes in the graph, we look to see if any of those factors reduced or canceled. We didn't have any that reduced, so there's going to be no holes in the graph. To find horizontal asymptotes, we compare the degree of the top and the bottom. Notice the degree of the numerator is 1, the degree of the denominator is 2. Whenever the degree of the top is smaller than the degree of the bottom, the horizontal asymptote is automatically the x-axis, or the equation y equals 0. Since we have a horizontal asymptote, there will be no oblique asymptote. To find x-intercepts, like always, we set y equal to 0. But since this is a rational function, we can take a shortcut and just look at the numerator and set the numerator equal to 0. So 6 times x minus 1, we'll set it equal to 0. We can divide both sides by 6. X minus 1 equals 0, and then add 1 to both sides, x is equal to 1. So our x-intercept is 1, 0. To find the y-intercepts, we make x 0. So we have 6 times 0 minus 1 over 0 squared minus 0 minus 6. That gives us -6 over -6, which is 1. So the y-intercept is 0, 1. Now we'll throw all of this together on a graph. Up first, let's look at the asymptotes. The vertical asymptotes are at 3 and -2. We also had a horizontal asymptote, which was y equals 0, the x-axis. We did not have any holes in the graph, but we do have x and y intercepts. They were both 1. And using those 2 points, we can get an idea for what's happening in the middle. We have asymptotes at x equals -2, and we have an asymptote at x equals 3. So it looks like something like this is happening. In the middle, anyway. Notice there's got to be something happening on the left over here and on the right due to the domain. We know that there's something here. If we wanted to algebraically find what's happening in those two regions, we would just do some point plotting. Plug in 4 to the function, see what it spits out, plug in 5, 6, and so on, and do the same thing on the left side. But since we're going for a very rough sketch here, let's use the calculator to estimate what's happening. So in y1, I'm going to use alpha y equals to get that fraction notation. And now we need to type in the function. We have 6 times x minus 1 divided by x squared minus x minus 6. Always double check, look for typos, and then we'll graph it. It looks like we do have the middle correct. We can see what's happening on the left and the right side now. We can use the trace button to get a point that is close by, just to get. So we have roughly 4, 2.5. So on the right side we have 4, 2.5 here. Then we'll just sketch the rest. We'll do the same thing on the left side using the trace feature. Let's see what a point would be on the left side. So -3, -3. Again, very rough estimate here. And we have a very rough sketch of this graph. Again, it's not super accurate. The main thing that will be tested on is finding the individual pieces algebraically from earlier. Make sure we can find domain, asymptotes, holes, and intercepts.